Hello, welcome to another Great Cow Basic tutorial for the Logic Green Technology LGT8XM chip family. So today, this is part 9. We're looking at pulse width modulation on many channels. Okay, I do have it on many channels. Great. Where are we? We're sort of well over halfway through these tutorials, and we're going to be looking at using the pulse width modulation on fixed frequencies and variable duties and various other combinations. So what does this chip look like? It comes on PCB, so it was a raw chip, but it's essentially, I'm using a 32 pin chip. They're a lot smaller and larger, but they come on boards like this Uno board, or I'm using the Nano board, the green one. What does it look like architecturally? Well, it looks like this. It has many different capabilities, and we're looking and have been looking at the pulse width modulation, and we've looked at that here. I'm pointing to the legend up here, and yesterday we looked at using one particular channel on the PWM, and where was it? P.5, it was this LED and a resistor here. Well, today we're going to put on another LED and resistor and another 2 LED and resistors down here, because we're going to be using more channels. So those channels we're going to be looking at are 0C 2B here. We're going to be using 0C 0B here, 1A and 1B. And there are others that you could use. I'm just using those as examples to put 4 LEDs in a stack. They're connected to D3, D4, D9 and D10 respectively. And what does that layout look like? It looks like this. This is a new diagram produced by Chris today, a bit clearer in terms of the PCB and chip. But essentially what we're doing, we put in these 4 LEDs here called D1, LED1 to LED4 on these ports as specified here. So you should go ahead and connect those, and I've already done that, and I'll show you that out on the lab. Here we go. So here we have the board here. We've got a set of LEDs here that are producing a square wave using the onboard PWM module inside of the chip, and it's got 4 channels that are working independently, and I'll show you that independence in a moment. I've got them connected in through 4 resistors you can see in a stack just here, and they're connected through these 4 blue wires underneath the chipset here. LEDs at the bottom right there, a switch on the right, and the pot are not used today because we've used those previously, but we will return to those. So what I'm going to do is I'm going to hook up an oscilloscope into these two of these ports so that we can see them operating, and you'll see me push these in here. I'm putting it in on that channel and this channel, and that gives me an oscilloscope that we can actually use that looks that will enable us to check out what's going on. So we're going to be using that particular LGT board mounted in this breadboard, and we're going to be using 4 PWM channels using at the same time using multiple timers. We can support different frequencies and different duties, and we can show you that. And to set it up, in recap, we did this yesterday. You set up a couple of 3 constants, and then use the command H for hardware, H PWM. Then we're going to peel that back, and we're going to examine 2 channels. And after that, I'll just show you where some of the help is for Great Cow Basic. So let's get down into the lab here, and there we go. So I've actually got the oscilloscope all hooked up and working. Let's have a look what's going on. Yeah, there we go. There's the oscilloscope. It's operating, is it? Yes. Excellent. We have an oscilloscope that's operating, and as you can see, we have got 2 square waves because I connected in 2 connections into the LGT board there, and that is exactly what we're going to be configuring now. So let's recap how we set this up. We set it up, we give it the chip option explicit to ensure that we've defined our variables. And I need to define my last variable here, which I have failed to do. I'm going to dimension a variable called bright. It's a variable that we're going to be using to send to the chip our value of the duty. So what do we need to do? We define the clock sources, and this is a set of constants that we set up, and those just tell the Great Cow Basic compiler to set up timer 0, 1, and 2. And they do relate to particular channels of PWM, so we'll look at that in the help. Then we're going just to define, enable those specific channels. Now, the first was set up the timer. Second is enable the channels. We're going to enable channel 2, 3, 4, and 7. That's the way they were created by the author of the library. And then we're just going to turn, the third part is we're going to turn the ports to outputs. And after that, we're programming. So this is set up. Now we're programming. And what I've done here, I've got a do loop that runs forever here and here. And then inside of that, I've got a variable in a for next loop, which sets from 0 to 255, and that equates from 0 duty to 100% duty, and it's exactly what you can see on the screen. In the picture below, you can see that all 4 LEDs are rising and dimming with that signal. And how do I then tell each channel what to do? I use PWM, the channel number, the frequency, and then the bright. And as bright's raising between 0 and 255, it will get brighter or dimmer. And that's the code. So we've got 4 channels running independently of each other. But how can I prove that to you? Well, what I'm going to do is I'm just going to take a copy of this code. I'm going to paste it into here, and we're just going to do some editing. Okay, we'll do some editing. Let's just take out a couple of these channels just to prove that we've actually got different channel control. So I've just saved it, and then I'm going to reprogram it under. I've saved it under a temporary address, and look, I've now got 2 LEDs running, those 2 right ones at the top. Once you can see that the frequencies in the oscilloscope are the same. We have the same frequency of, let me just check on the big oscilloscope, 10 kilohertz. I'm going to change one of the LEDs to 5 kilohertz. Simply change the variable, which is the second parameter on channel 7, recompile it, and you can see that there's some difference in terms of the oscilloscope. And you can see that the LED looks similar, but there is something very different. So let's just set up this oscilloscope. I've just selected channel 2 as my clock source, and now you can see that the frequency is twice the other. It's therefore slower, but the duty is relative. So we've actually got independent clock to duty. And if I change the source, I say not bright, it will actually do us an inverse signal. So it's going to invert my values of 255 to the opposite of 255, which is a not statement. And hopefully we'll see the LEDs do the opposite. One's going on, one's going down. And they're doing that at different frequencies. So what you've got is independent pulse width module configuration. But be very frank, you can still use all the AVR or LGT registers to control it. This is the easy way that you can do it. This has taken 10 bytes of RAM to complete all this and a few seconds. However, you can do the same, as I just said, in the registers. So what I wanted to show you is how you control multiple channels, which we've done, and you can have independent frequencies and independent duties, which I've also done. Let's just go back to PowerPoint to see what else I wanted to cover today. I also wanted to cover some help. When you're in the IDE, I think I've shown you this before, when you're in the IDE, you can press F1. So if we go back to the, I'm going to look at my desktop. This is my desktop. If I highlight a particular command like weight, I press F1, I get the weight. And this is important because you're going to get your syntax and a bit of an explanation in here about what's going on. PMW, F1, I get the command and the syntax, which is great. But there are other methods if you don't have Windows, because I'm showing you Windows. Let's assume for a moment you don't have Windows. How would you then be able to go out to a file that's for Windows itself? Well, we supply and provide you a set of links into different resources. And those resources are available on these two URLs, and I'll show you those. So the first one is actually our help. We actually have the help online. You can go to this URL, which is a sourceforge.net/help address for our project. And then you can type in, I'll do the weight because that's what I did before. And it says that the significance of this is very high. And it will actually show you the same syntax, the same help, but you can then use this within your offline system or within Linux or Apple, etc. You can also do the same. I'll come back to that because I don't know why it's slow. You can also do the same in GitHub. If you go to our GitHub site, there's a great Cal Basic help. If you go into the wiki, you can type in it in here. You can do a search in this dialog box, select weight, and you get the same help. Exactly the same help. It is the same. We compile it in 8 different methods. I think we have 8 different ways. You can get this in PDF, Web 5, HTML, HTML5, CHM, and Wiki, and I think there's others as well. But you're going to get exactly the same level of help depending on what your solution is. So if we want to look at the fixed mode for AVR, we just come into here and exactly what the code was that we've been using. So I wanted to show you 2 things today, which was how to do PWM on multiple channels and a quick review of the help. You'll see some of this information I've actually lifted from the help itself, just so that you've got it in this PowerPoint, but it's extremely simple to use. So this is part 9, using PMW or many channels. Do enjoy.